In this video, we'll be looking at domain and range of a relation or a function. In terms of a domain, now recall that a domain is nothing more than what we would like to call the set of x values. Now, I don't like to call it the set of x values that we can plug in. I say that because this is more appropriate the input values of the function. In terms of a range, we will be looking at the, again, so-called y values. Again, I don't like to call them the y values, but it is more or less the output values. Now, when looking at a relation, a more appropriate way to view a relation is simply identifying a table of values. So I have an x and a y, and if I have, say, 1 and 3, 2 and 4, 5 and 7, this relation happens to be a function because every single x value that I plug in that they gave me, every single x value that I can work with, gives me back one and only one y value. So this is going to be a function as opposed to a relation, number one. Number two, if I was looking for the domain, the set of x values I'm allowed to plug in, we're going to use this little set notation bracket. My domain is 1, 2, and 5. Those are the values that they are allowing me to plug in based on the definition of this function. My range, however, is the set of y values. And again, we're going to use the set bracket notation of 3, 4, and 7. So this is the domain and range of this particular function. Now, I might have other types of functions, or I might have other type of relations. For instance, if I were to see x, y such that I end up with 1 giving me 3, 1 giving me 2, and 3 giving me 4, then I would say that this is not a function. And the reason why this is not a function is specifically because if I ask you to plug in 1, you don't know which y value to give back. The input being 1 provides me with an unknown output. But that doesn't mean that I can't have this as a situation. It just means that it is not a function. So my domain for this one, and again, we can limit and simplify this to simply be the set of 1 and 3. I'm allowed to plug in 1. Yeah, sure, there's two different values I can plug it in for, but there is one domain value of x. And then my range value is going to end up being a 3, a 2, and a 4. Now, arguably, we should probably rewrite this in the appropriate order, and that appropriate order is 2, 3, and 4. It's the set of values that we're allowed to plug in, arguably from the lowest value to the highest value. But either one of these two values will work for the range. So this here is a relation such that we understand our domain and range from that. Now, likewise, when we're looking at functions, and specifically functions such as f of x equals to 3x, the question revolves around the concept of what x values or what input values am I allowed to utilize for this. Well, if you try to go ahead and plug numbers in, again, don't forget that plugging numbers in is simply a nice, simple way to view what the function is supposed to be doing. I could say plug in -3, -2, -1, 0, 1, 2, and 3. So if I plug these x values in, plugging in -3 gives me -9. Doesn't seem like there was any issue when attempting to plug this in. Keep in mind, when I plug it in, it's going to be 3 times -3. This is, again, going to be -9. And then I'm going to attempt to plug in -2, so it's 3 times -2, which gives me -6. So that's the output, that's the range for that function. And then when I plug in -1, I'm going to get -3. When I plug in 0, I'm going to get 0. When I plug in 1, it'll be 3, 6, and 9. Now, the unfortunate part about this is not my domain. This set of x values right here is the set of x values that I have chosen to plug in. Up here, these tables were given to us. Down here, this was the only thing that was given to us, was this function. And I've selected a set of x values to plug in. Could I instead then plug in 3.5? Is there anything stopping me from plugging in a decimal? How about 3.1, 3.11? How about a fraction, say 7/4? If I were to try and plug any of these numbers in to this x value, is it possible for 3 times that number to spit back a value? And the answer is yes. The domain for this particular function, and we'll use d sub f as the notation. This is the domain of the function f. And again, this is the notation, the function f in respect to x is 3x. Well, the domain for this is actually going to be all real numbers. Now, all real numbers can be written as capital R with an extra slash down it. That is, again, notation for all real numbers. Another way to write it is interval notation, such that we contain all values from -infinity to infinity. And the third possible way to write this is the set notation, such that it is all x's, such that my x value sits between -infinity and +infinity. And again, these are the 3 different ways you could write down all real numbers in terms of the domain. For the range in terms of f, and again the same argument is going to hold. If I were to try and plug in numbers, is it possible that every single value of y is a possible return value? And for this particular example, the answer is yes. So again, once more time, is going to be the all real numbers, negative infinity to infinity, interval notation, or my set notation, which is the set of all y values such that negative infinity is less than x is less than infinity. Now again, it might be hard to grasp what these individual notations end up being. However, it doesn't change the fact that all three of these things say the same thing. However, the third case, this one here and this one here, provide us with a lot more information, knowing that the domain is in terms of x and the range is in terms of y. And it's all x's, sorry, this should be a y value. All x's are between negative infinity and positive infinity, and all y values are between negative infinity and positive infinity. So this is one way that we could view domains. Now, a common idea that we're going to have to make sure we don't forget is there are three different functions that have domain errors. And when I say that, I mean the domain of a radical equation, or radical function more appropriately, the domain of a rational function, and the domain of a log function. These are three functions we will come to work with on a regular basis. They all have domain issue, meaning the value of x will be restricted. These will have restricted domains. So, if these are the three functions that have restricted domains, the question is how are they restricted? Well, rationals, keep in mind, there's something like 1 over x, which means you're not allowed to divide by 0. So x, in this case, the denominator in this case, cannot be equal to 0. So we've restricted whatever rational function is that the denominator cannot be 0. A radical equation is, say, the square root of x. Well, for the square root of x, all the stuff inside there must be restricted to greater than or equal to 0. If we were to try and plug a negative number in for x, we end up getting the square root of a negative, which is actually an imaginary number and not real. And therefore, if it's not real, like these all real numbers, the domain cannot be encompassing those values. The log function actually looks like this, and it's going to take into account both of these restrictions. So the log function, everything inside the log must be strictly greater than 0. These domain issues will come around again in another video, or at least in lecture. However, it is extremely important to note that these three restrictions are a common occurrence, and we must be comfortable with identifying them based on their equations that we have been given.